Tornadoes can occur at any time of year, but peak season is typically spring and early summer. While most tornadoes rotate cyclonically, a small percentage rotate anticyclonically. The widest tornado on record was 2.6 miles wide, occurring in Reno, Oklahoma in 2013. That was just one of many fascinating facts. Keep watching and discover how tornadoes are born. Introduction to nature's fury. Tornadoes are one of nature's most awe-inspiring and destructive phenomena. These violent rotating columns of air can unleash incredible power, leaving a path of devastation in their wake. But how exactly do these swirling giants come to be? It's a complex dance of atmospheric ingredients, all coming together in just the right way. Understanding tornado formation helps us appreciate the immense forces at play in our atmosphere. It's a fascinating journey from calm skies to a terrifying vortex. Let's peel back the layers of the atmosphere and uncover the secrets behind these incredible storms. The essential ingredients. For a tornado to form, you need a very specific set of atmospheric conditions. Think of it like a recipe, where each ingredient plays a crucial role. The first key ingredient is warm, moist air, typically from the Gulf of Mexico, providing the fuel. Next, you need cool, dry air, often from the Rocky Mountains or Canada. When these two air masses meet, the warm air rises and the cool air sinks, creating instability. This atmospheric instability is the engine that drives severe thunderstorms. The role of wind shear. Perhaps the most critical ingredient for tornado formation is wind shear. This isn't just any wind. It's a change in wind speed or direction with height. For instance, winds near the ground might be blowing from the south, while winds higher up blow from the west. This difference in wind creates a horizontal, invisible tube of rotating air in the lower atmosphere. Imagine a rolling pin spinning sideways. This horizontal rotation is the first step towards a vertical vortex. The birth of a supercell. When all these ingredients come together, warm, moist air, cool, dry air, and significant wind shear, they can give rise to a special type of thunderstorm called a supercell. Supercells are powerful, long-lived storms characterized by a rotating updraft. As the warm, moist air rises rapidly within the storm, it tilts that horizontally rotating tube of air upwards. This transforms the horizontal spin into a vertical one. Now, the entire updraft of the thunderstorm begins to rotate. The mesocyclone takes shape. This rotating updraft within a supercell is known as a mesocyclone. It's essentially the heart of a potential tornado. The mesocyclone can be several miles wide and extends through a significant portion of the storm. As the air continues to rise and rotate, the mesocyclone strengthens. It acts like a giant atmospheric drill, pulling more air into its rotation. This is where the storm truly starts to organize itself for tornado production. From mesocyclone to tornado. Not every mesocyclone produces a tornado, but it's a necessary precursor. For a tornado to form, the rotation within the mesocyclone needs to tighten and intensify. This often happens in the lower part of the storm. As air rushes into the base of the mesocyclone, it stretches the rotating column vertically. This stretching causes the rotation to spin faster, much like a figure skater pulling their arms in to increase their spin. This intensified, rapidly rotating column then extends downwards, eventually reaching the ground as a visible tornado. Fascinating tornado facts. Tornadoes are measured on the Enhanced Fujita, or EF, scale, from EF0 to EF5, based on the damage they cause. An EF5 tornado, the strongest, can have winds exceeding 200 miles per hour. The United States experiences more tornadoes than any other country, averaging over 1,200 per year. Tornadoes can occur at any time of year, but peak season is typically spring and early summer. While most tornadoes rotate cyclonically, a small percentage rotate anticyclonically. The widest tornado on record was 2.6 miles wide, occurring in Reno, Oklahoma in 2013. Some tornadoes can travel for dozens of miles, while others dissipate quickly. The sound of a powerful tornado has been compared to a freight train. Despite their destructive power, the average tornado only lasts for about 10 to 15 minutes. Other types of tornadoes. While supercell tornadoes are the most common and often the most powerful, other types exist. Landspouts and waterspouts, for example, are non-supercell tornadoes. They form from rapidly growing cumulus clouds, often without a pre-existing mesocyclone. Waterspouts form over water, while landspouts form over land. They are typically weaker than supercell tornadoes but can still cause damage. Multi-vortex tornadoes, on the other hand, are supercell tornadoes that contain two or more smaller, intense vortices orbiting within the main circulation. Conclusion: respecting nature's power. The formation of a tornado is a testament to the incredible power and complexity of our atmosphere. It's a precise alignment of temperature, moisture, and wind shear, culminating in one of nature's most awe-inspiring displays. From the initial instability to the final destructive vortex, each step is crucial. Understanding how tornadoes form helps us appreciate the science behind weather and the importance of preparedness. These swirling giants remind us of the dynamic forces constantly at play around us, urging us to respect the raw power of nature. Thanks for watching. We hope you enjoyed this video. If you did, don't forget to hit the like button and subscribe for more mind-blowing facts.